So today we are going to discuss about the Bernoulli Theorem. So according to Bernoulli, fluid has energy due to pressure, motion and gravity, and for the steady flow of ideal fluid, sum of all these energies per unit volume is always constant. You know guys that this law represents the conservation of energy, means the Bernoulli Theorem is also called the conservation of energy. We studied conservation of mechanical energy, and now this is conservation of energy. They look similar to each other. You'll get to know further in this video. Now there is a small note here which I have written that this is not applicable in rapid flow, turbulent flow and viscous force. Now the main thing is that how should we derive this? How should we derive the equation of Bernoulli? So the proof is that we have to consider delta M mass of ideal fluid. This is delta M mass of ideal fluid having volume delta V which is moving from A to B. Now we know that work done is equal to P delta V. This is a pressure volume work done and we can write this as 1. We can write this as P1 minus P2 delta V. Why we wrote P1 minus P2? This is basically the pressure difference. This is height H1, this is height H2. This is the pressure difference, and you know that change in energy, which is delta E. It is equal to half delta M V2 square plus delta mg H2 minus half delta M V1 square plus delta mg H1. Now, we know that what is work energy theorem. So let me tell you those who don't know about work energy theorem. Work energy theorem states that total work done is equal to change in kinetic energy. But in this case, work done is equal to change in energy. P delta V, it is very similar derivation. Half delta M V2 square plus delta mg H2 minus half delta M V1 square minus delta mg H1. Guys, please like this video if you are actually getting helpful content from this video. P delta V is P1 minus P2. Delta V is equal to half delta M V2 square. I'm just repeating the step. In this step, the change is just that I have written the work done as P1 minus P2 delta V, same as I have written it above. Now P1 minus P2 would be half delta M by delta V V2 square plus delta M by delta V G H2 minus half delta M by delta V V1 square minus delta M by delta V G H1. Now how this is, I've written like delta M by delta V, delta M by delta V. How is it possible? So what I did in this step is that this delta V, I divided the entire equation with delta V. I divided both the sides by delta V. That's why it came here. Now P1 minus P2 is equal to half rho. Rho is the density. Delta M by delta V is rho. We know that density is equal to mass by volume. It's so simple, guys. Plus rho G H2 minus half rho V1 square minus rho G H1. Now I'm just arranging the elements here. Plus rho G H2. Now what we are seeing here is that P plus half rho V square plus rho GH is always constant. You can take a screenshot of this Bernoulli theorem definition and some pointers here. These pointers will be so useful to you in your exam. And guys, let me tell you, this is one of the most important questions of all the CBSE physics examination. and it's so interesting. Which, guys, I hope you like this video. If you like this video, then don't forget to give it a big thumbs up and subscribe to this channel, please. Thank you so much for watching and share this video maximum.